Okay, so we're looking at examples 1A, 1B, and 1C at the bottom of the page, so let me zoom in on those. I'll kind of come over here a little bit. So this first one, 1A there, you can see it on the right. The first thing you can do with that one is you can do, here I'll label it as 1A over here. So on 1A, you can do the 16 divided by the 8. That's going to give you 2. And just like I showed you on the board, you'd have x to what power? Well, you subtract the power, so it'll be x to the what? 9th. Yep, so it'll be x to the 9th. So that one's just 2x to the 9th. So now that I already showed you that on the board, that went pretty quick. So that's 1A. Now what you're really doing here then is they call these rational expressions, but they're really algebraic fractions. So what you're going to do is you're just reducing algebraic fractions. So let's look at 1B. Now 1B, we're going to have to do some factoring. All right. So if you look at 1B there, there's no common factor for 3, 1, and negative, or 3, 1, and 4. So we're going to have to use that technique I showed you last week. So let's set this thing up. So the numerator is 3x plus 4. I'll just do this one down here. In the denominator, we're going to factor this. And because the a here is not 1, right, the method that I showed you is you're going to have to put a 3x and a 3x. And now I'm not going to write all this out as much as I was before for you guys. We're going to multiply a and c together, right? So a times c on this one is going to be 3 times negative 4. That's a negative 12, right? And then the number out in front of the x to the first power term there, that is a positive 1 right there. So if I set up that little, I don't know, I guess I could call it a little chart. We need two numbers now that are going to multiply to a times c, which is negative 12, where the same two numbers are going to add up to positive 1. So what do you guys got? Who's got two numbers that multiply to negative 12 that add to 1? Say it again. 4 and negative 3. So a positive 4 and a negative 3. That works, right? So if we multiply these together, we get negative 12, but if we add those together, we get positive 1. Now, we also got to look at both of those factors and see if there's a common factor, and there is. The one on the right could be divided by 3. So you could divide this one by 3. Okay, so you got to remember that step. And then remember to divide this into both of these. The reason you divide that 3 into both of those terms is that's like the distributive property. Dividing by 3 is the same thing as multiplying by 1/3. So you're really distributing a 1/3 onto that quantity 3x minus 3. So anyways, let me rewrite this again one more time then. So what we've got now is we've got the numerator is now 3x plus 4. And then this denominator now becomes 3x plus 4 times the quantity. Well, if I do the 3 divided by 3 in this term and then the 3 divided by 3 in that term, that second factor is just going to be x minus 1. Now, what cancels out? You got a multiplication in the middle right here. Let me slide over a little bit for you guys so I got some room. You guys see something that would cancel out? What's 3x plus 4 divided by 3x plus 4? Or I should say it this way. What's the quantity 3x plus 4 divided by itself? What's anything divided by itself? What's that? It's 1. Yeah, so what you can do now is you can take this entire, you don't go in here and individually cancel the 3 and the x and all that. You say this entire quantity, 3x plus 4, cancels that entire quantity, 3x plus 4, like that. Anything divided by itself is 1. So that means you get a final answer of 1 over the quantity x minus 1. All right. And I think it also talks about identifying the x values for which the expression is not defined. We'll do that later on. We're not going to focus on that. For now, I just want to get the answer. You guys okay with that? Okay. Let's try 1c then. Oh, by the way, can you guys see that since everything canceled out in the numerator, it leaves you a 1, okay? All right, so let's look at 1c here. Now 1c, this one will be a lot more work here. There are no common factors again, other than 1, right? There's no greatest common factor greater than 1 for 6, 7, and 2. There's also not a greatest common factor greater than 1 for 6, 5, and 6. So we're just going to have to factor these with the method that I showed you last week. So let's go ahead and try this one. So let's see. So we're going to do, A is not 1 here, so A is 6. So we're going to write 6x and 6x. In fact, same thing in the denominator, right? So we're going to write 6x and 6x. Now in the numerator up there, the a times c here, that is going to be a positive 12. And then the middle term coefficient there is a 7. So we are going to need two numbers. We're going to need two numbers that multiply to a times c, which in this one is 12. And then we need the same two numbers to add up to positive 7. So can you guys think of two numbers that multiply to 12 that add to 7? 3 and 4, good. So we got a positive 3 and a positive 4. Should make a better 3 there. Now, you notice I'm not even filling in that chart. I'm just kind of setting it up to help myself realize what I got to do. All right, then on the bottom here, same thing. But this time on the bottom, or the denominator, my a times c here is 6 times negative 6. So I'm going to need two numbers that multiply to negative 36 that add to negative 5. So let me set that up. So again, a times c here is negative 36, and b right there in the middle, the coefficient of x to the first power is a negative 5. So I need two numbers that multiply to negative 36, where the same two numbers add up to negative 5. Anybody got that one? Say it again. I think the other way. So negative 9, positive 4? Yeah. That's good, though. So we need a negative 9 and a positive 4. So if we multiply these two numbers together, you can see we get negative 36. But if we add these two numbers together, we get our negative 5. Okay, so then we got to look at each of these and decide if there's a common factor to divide out, because right now this is not going to work, right? Like right now, if we did 6x times 6x, well, that would give us 36x squared. So let's see, what can we do? We can divide this one by 2. We could divide that one by 2. And we could divide this one by 3, right? And we could divide that one by 3. Well, I think you guys can see that it doesn't really matter. Can you see that those 6x plus 4 ones are going to cancel out? So maybe we can kind of skip a step here. This one right here, this whole thing right there is going to cancel out with that one, right? Those are both going to be 3x plus 2. So then let me move over a little bit. So then all I got to do here is just divide each of those by those common factors. So let's see. This one over here, we're going to divide the 3 into both terms here and divide the 3 into both terms here. So that gives us what? 2x plus 1 over 2x minus 3. I think that's good. So that's really reducing fractions. Pretty exciting, huh? Okay. All right, so let's, you guys got all that stuff? All right, so let's move on from there. I think that was it on that page. So let's go to the next page. Again, you guys should be copying these examples down, because then I said it's open note on the test, right? So you copy these down and you use them on the test. All right, the next one here, let's see, what should we discuss here? Let me throw this little discussion in real quick. I want to talk about why you don't go in, like, let's say I gave you something like this. Like, if you have x squared, I don't know, x squared plus 5, and then, hold on, let's do this. X squared plus 25, and then you have like x squared, I don't know, plus 5 or something. All right, nothing there cancels out, you guys. What I'm trying to say is, you see how these terms are separated by addition or subtraction right here? Those two terms are separated by addition or subtraction. You can't cancel anything out. All right, people look at that and they want to go like this. The common error is they want to see that and they want to go, oh, I'll just cancel those out because x squared over x squared, that's 1, right? And 25 over 5, let's see, I'll cancel that and make that a 5. Okay, you can't do that because the x squared and the 25 and the x squared and the 5, those are separate terms. Those are separated by addition or subtraction. That would be saying something like this. Let me get all this out of there. That would be saying, like, if I gave you, what should I give you? That would be like if I gave you 4 plus 9 over 4 plus 7. Oh, I could just cancel those, right? And the answer is 9/7, 9 over 7. Well, that doesn't work, right? That's 13 over 11. That's not 9 over 7. All right. Now, if there's a multiplication in there, if this was a multiplication right here, so if you had a multiplication right here and right here, then you can do that, right? Because that'd be 4 times 9, that's 36 over 28. That would reduce to 9 over 7. So yeah, you can do that when it's multiplication. Same thing up here. If I made this multiplication, if I did that, now you can do what I showed you before. Now you could cancel those out and say that's 1. And then 25 divided by 5 is 5. The answer would be 5. Okay? Is that pretty clear? So don't go in there. You got to factor these things first, and then you got to cancel the factors, okay? All right, let's get rid of all this and keep going. That was just a little side discussion there. All right, so now we're not going to do all these. So on this one, let's do example 2A here. So we got to fit this in over here, I think. So 2A. Oh, I forgot one thing. This one's going to need a little discussion too before I do it. So I got one more thing to show you. Hang on with me. So bear with me. What does something like this equal? What if I give you like x minus 2 over 2 minus x? Anybody got an idea what that would be? Well, like if I gave you x plus 2 over 2 plus x, would those cancel out? Is x plus 2 the same thing as 2 plus x? Yes or no? Yes. Yeah, that's like saying like 3 plus 2 is the same thing as 2 plus 3, right? Addition is commutative. So yeah, now when I cancel these, you'd have to say, okay, this whole thing cancels that whole quantity down there. And the answer would be 1. Got a guess on what the top one would be now? How about if I put some numbers in there? What if on the top one, what if we made this, let's see, what could we do? Let's go, how about 5 minus 2 over 2 minus 5? What does that equal? That's 3 over negative 3, guys. What's that? Don't be shy. This is 3 over negative 3. What does that equal? What's that? Yeah, negative 1, right? A number divided by its negative is negative 1. So that means this thing over here is actually negative 1. So anytime you see that like that, it's got to be a minus in the middle. And you see that these two terms are just reversed on the top and the bottom. Anytime you see that now, you know that that's going to be -1. Now in the book, they would want you to be fancy, and maybe on this bottom one, they would say, okay, let's factor a negative off of there and make that x minus 2. Do you see that that's the same? Because you could distribute this negative, so negative onto the x would give you a negative x, and then the negative distributing onto the -2 would give you a +2. And then you can see that those quantities would cancel out and leave you with a -1. But I would just rather just look at it and have you know. You're going to run into that in the assignment, so be aware of it. All right, now let me get rid of all that and let's do the other problem. So here we go. So we're doing this 2A example here. I'm going to come over here on the side and do it. So we have got, let's see. We have got, I'll just rewrite the problem here for you guys. So this is 10 minus 2x over x minus 5. So in that numerator there on 2A, they want you to factor out the greatest common factor. So what's the largest number greater than 1 that divides evenly into 2 and 10? You can say it. 2, good. So you're going to factor a 2 out in that numerator, and you're going to put one set of parentheses like that. And then you're going to fill that in. Remember, it's kind of like you're doing the distributor property backwards. So you're going to say 2 times what would give you 10? Well, that should be a 5, right? And then you're going to say 2 times what would give you 2x? And that would be x. All right, so you factored out a greatest common factor in the numerator. Now, what does this part equal? Good. Yeah, it equals -1. Do you see that? 5 minus x over x minus 5. Those are going to cancel out and leave you with a -1. So you are going to cancel these. All right? And now it doesn't really matter whether I put that -1 into the numerator or into the denominator. Just for the heck of it, I'm going to put it down here. Well, then I've got 2 divided by -1. That's going to be -2. So your answer is -2. All right. Well, now the rest of this lesson, we're going to talk about multiplying and dividing fractions. Let's pick one of these. You guys all got that one? I'm going to move on. So let's look at what we got. Let's look at example. I don't know which one looks good here. I should probably do one like this 3A. So let me try to zoom in on that a little bit. So I'm going to write 3A over here again on the side so you guys can see it. This gets kind of messy. So let's see if I can do this. Let's go, we got a 2, an x to the 4th, a y to the 5th, over 3x squared. And that's times, and then we got a 15, we got an x squared, and then we've got a 8x cubed y squared. Okay? Now this is all multiplication up here, okay? So if you're going to multiply fractions, you just multiply straight across the top, straight across the bottom. But do you guys remember that you could cross cancel and you were able to reduce? Remember doing that stuff? Like if I had like 2/3 times, I don't know, 9 over 14 or something. Remember you could divide this 2 by 2 and you could divide the 14 by 2. So then you could do stuff like you could say 2 divided by 2 is, oh, let me get a different color. You could say 2 divided by 2 is 1, 14 divided by 2 is 7. You could do the same thing here. You could say 3 divided by 3 is 1, and 9 divided by 3 is 3. Then you would multiply straight across the top, straight across the bottom, and you would get 3/7. So what that does for you, if you cross cancel first, is it reduces your answer. You don't have, otherwise, if you multiply straight across the top and straight across the bottom, then you have to reduce your fraction when you're done. Same idea with the algebra one that I wrote up there at the top. So do you guys see any numbers that I can cross cancel with there? I'll wait for you guys. The 3 and the 15, good. So we can do, again, this gets kind of messy, so I'm going to try to do this as neat as I can. So we can cancel the 3. 3 divided by 3 is 1, so that cancels out. And 15 divided by 3 is 5, so we got a 5 there. What else? Don't be shy. We got to keep this thing moving. We got a few more examples to do. The 2 and the 8, yeah. So you could say 2 divided by 2 is 1, so that cancels out, and 8 divided by 2 is 4. So now we're there. Now what about all these x's and y's and stuff? Do you see right here, now that I got the problem there, maybe I can zoom in a little bit more on this thing. So do you guys see that, like right here, I've got an x to the 4th over x squared. Do you see that? What would that leave you? So right there, you got x to the 4th over x squared. That's the rule I went over on the board at the start of the hour, right? Where do you got more x's multiplied together, top or bottom? What's that? You guys got masks on, I can't hear you. Where do you got more x's multiplied together, on the top or the bottom? Come on, guys. I'm serious. If you guys got to get with this, because if you can't do this factoring stuff and canceling, you can't do any of chapter 8. Like, you got to get this. So on the top, you got x times x times x times x. On the bottom, you got x times x. So where do you got more x's multiplied together? What's that? On the top, how many more you got on the top? 2. So this would actually become an x squared then, right? Now, I'm not gonna do it that way. I just wanted to show you that one. The other thing you could do is you can cross cancel the variables. So what you could do is, you see the x squared here? You can cross cancel that over there with that x squared on the top on that right fraction. As long as one of these factors is in the numerator and the other one is in the denominator, it doesn't matter if they're directly one over the other one or if they're across from each other like that on a diagonal. So what I'm telling you right now then is I can cancel out this x squared with that x squared. Actually, let me try this again. So I can cancel that x squared right there with that x squared right there. So x squared over x squared, that's 1. Let me get this out of here. So what else can I cancel now, guys? What else cancels? Well, I guess that nobody can answer this question. I have to tell you. I got an x to the 4th on top, and I got an x to the 3rd on the bottom. Do you see that? They are right here. Here's the x to the 4th. And over here on that diagonal down on the bottom over here, I got an x cubed, right? So if I cancel those, what am I going to be left with? How many x's? Just 1. Where is it going to be, on the top or the bottom? On the top. Good. Now we're getting with it. Yeah, so we're going to cancel this out completely. That's a 1. And now this is kind of weird. You got to keep track of this stuff. I'm going to make this a x to the 1st power now instead. Do you see that? All right, and then I got a y to the 5th and a y squared. Where do I got more y's multiplied together? Top or bottom? Top. How many I got left? 3. Perfect. So now here, I'll do this in a different color. So we're going to cancel this one out completely. So that's a 1. And then that's going to leave us with 3 y's multiplied together on the top, which gives me a y cubed right there. All right, now it's kind of a mess, but you got to multiply straight across the top and straight across the bottom, and you'll be done. So let's do that. So let's see, we're going to multiply straight across the top. What do we got up on top left? Well, that's a 1. This is a 1. That's an x to the 1st. That's a y to the 3rd. That's a 5, and that completely canceled out, so that's a 1. So the only thing I got left up on top is a 5, an x to the 1st, and a y cubed. So let me write that. We can multiply in any order because multiplication is commutative. So I'm going to write 5 x to the 1st power, y to the 3rd power. And on the bottom, what do I got left down there? I only got one thing. What's that? Good, yeah, the 4. The only thing left on the bottom is this 4 right here. Because these canceled out completely, that's a 1 times 1. And these canceled out completely, so that's a 1 times 1. So all I have on the bottom is just a 4. And then that is your answer. All right. I think that might be it for that page. So let me take a look at this. Yeah, I think that'll do it for that. Let's go to the next page. Now we have got division of fractions. That sounds like fun. So let's do one of these. So I'm looking at this 4b example right here. Okay, do I need to show you anything on the side? I probably do. Maybe I'll come over here on the other side. So something you got to know on the side, we didn't talk about this in class, you did these on Delta Math. That is the fact that if you have like a squared minus b squared, well, first of all, if that was a plus, that would be prime. But since it's not a plus, it's a minus, then that is going to factor into the quantity a plus b times the quantity a minus b. And again, we didn't do that in class, we did that on Delta Math. So you got to know that one for sure. And you should see that that does work, because if you do a times a, you get a squared. If you do b times negative b, you get negative b squared. And then hopefully you can see that the middle term would cancel out. If I multiply these two together, I get negative ab. If I multiply these two together, I get a positive ab. And then you add them together and you get 0. That's why there's no middle term. So we got to know that for sure. Because we're going to get one on this one that says, I believe it says, you have x squared minus 9. So what you guys are looking for in these problems, like right here, you're looking for the perfect square numbers. The perfect square numbers are like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, right? 4 squared is 16, 25, 36, 49, 64, 81, 100, 121. You're looking for all those perfect square numbers. Because this one right here would be x squared minus 3 squared. So that is called the difference of two squares. And that would factor into, with the rule I just showed you, that would factor into x plus 3 times the quantity x minus 3. So you're definitely going to need that. We're going to do that a lot in Chapter 8. So you guys are really going to have to work. This Chapter 8 and 9 stuff is not going to be easy, all right? Once we get beyond that, we do probability and we do series and sequences and trigonometry, and the algebra's not that heavy, but this is heavy algebra stuff in Chapters 8 and 9. So if you can't factor that stuff we were doing last week, you're going to be in trouble, and you got to be able to do it fairly quickly too. Not that I'm trying to scare you. Okay, so here we go. So we're trying to do this one here now. All right. So we're doing this 4b example here. So let me get this where I get as much room as I can. Okay, so let's try this thing. Well, first of all, how do you divide fractions? See that division right there? What's the rule, or what's the saying you guys use for dividing fractions? Anybody know? How about if I gave you a hint, like KCF? What does that stand for?
Keep, switch, flip.
Yeah, keep, change, flip, right? So we keep the first fraction like it is. Then we change the division to a multiplication. And then we flip the second fraction over, right? So I'm kind of got to do this all at once as I'm factoring it. All right, so let's start this stuff. So we look at this first trinomial right here. We've got 2, 7, and 4. There's no greatest common factor there greater than 1. So we're just going to have to factor it. So with the method I showed you last week, we're going to start this thing out. We're going to make a 2x and a 2x. All right. And then, let's see, do I have some room here where I could do this? Maybe on the bottom down here, I could do it out of the way. So for this one, our a times c here is going to be 2 times negative 4 is negative 8, and our b is going to be negative 7. So down here on the bottom, I guess, I'm going to need two numbers. I need two numbers that multiply to a times c, which is -8. And I need the same two numbers to add up to the b there in the middle, which is -7, the coefficient of x. So anybody got that one? Yeah, -8, +1, right? So we're going to put a -8 in here and a +1. So then if we, hopefully you guys, can you guys see that okay? Yeah, okay. So then if we multiply these together, we get -8. If we add those two numbers together, we get -7. But then we got to remember this one on the left right here, this quantity has a greatest common factor of 2. So we're going to have to remember to divide that one by 2. All right. And then the denominator on this one is the one I just did off the side there. Do you see that's the difference of two squares? That is x squared minus 3 squared. So that one is going to factor into x, the quantity x plus 3 times the quantity x minus 3. All right, let's keep going. We're going to change the division to a multiplication, and then we're going to have to flip this thing over. So the first thing we got to notice is the denominator on the right. That does have a greatest common factor. There is a greatest common factor for 8, 28, and 12. What is it? Largest number greater than 1 that divides evenly into 8, 28, and 12.
4.
Good. So that's a 4. So we're going to have to factor it. Now that's going to end up on the top, remember, because we're doing keep, change, flip. So I'm going to have to factor out a 4. And then I'm not going to go too many steps on this one. So then that's going to leave me what? 2x squared minus 7x plus 3. I think that's right. 8, -28. Yep. And then, and now this one's kind of tricky. You got to look at this one. This one's actually the difference of two squares also. Because that could be 2x squared minus 1 squared. Right? 2x times 2x would be 4x squared, and 1 times 1 would be 1. So that one's also the difference of two squares, just like that denominator on the left was. So that one is going to, remember I'm flipping this thing, so remember that one now, that one's going to factor into 2x plus 1 times 2x minus 1. All right, now, before I can finish this thing, I got to factor this thing right here, right, that one. So let's see, I'm going to have to slide over. Let me get the rest of this stuff so I know what the heck I got here. Let me finish this little thing up here. We never finished dividing this over here by the 2 right here. So just make a note of that. That's going to be what? 2 divided by 2 is 1, so that's going to become x minus 8 divided by 2 is 4, right? That's going to be a x minus 4. Okay, so let me start writing this over here so I can move over. Do I have room over here? Yeah, I do. So I'm going to have x minus 4. Sorry, I got to rewrite all this. So I'm going to have a x minus 4, and I'm going to have a 2x plus 1. And then on the bottom, I'm going to have a x plus 3 times the quantity x minus 3. And let me slide over some. And then what I want to work on, right, well, I guess I'll get this in here. And then we're multiplying by, and I've got a 2x plus 1 here. And a 2x minus 1. I did remember to flip that, didn't I? Yeah. Okay, and then the issue I got to do now is the one I've got to do now is I've got to factor this thing right here. That one. So that one right there, I'm still going to have that 4. So that 4 is going to sit there still. But then I've got to factor this thing. And actually, let me give myself a little more room here. Still don't have what I want there, but that's okay. It's a long lesson. I'm getting tired. Okay, here we go. So this one. So for this one right here, this one, we are going to need two numbers that multiply to a times c, which would be 2 times 3 is 6, where the same two numbers would add up to the coefficient of x to the first there, which is negative 7. So can you think of two numbers that multiply to 6 that add to negative 7? Negative 6, negative 1. Okay? So then, oh, and also you got to remember on this one, since this is a 2 right here, I don't know if you can see that right there. There's a 2 in front of that x squared. That means when I go to factor this over here on the side, I've got to write 2x here and 2x here. And then we decided that the answer to this part was negative 6, negative 1, right? So we're going to write minus 6, and it's a negative 1, so we're going to write minus 1. All right, so then we can still divide this one here now by 2. But this one right here is all done. Bear with me because I'm even getting tired of this problem. So I'm going to rewrite all this stuff one last time, and we'll be done with it. So let's see, what can we do here? So what we've got now is that we've got an x, we have got x minus 4. We've got a 2x plus 1. On the bottom, we've got an x plus 3 and an x minus 3. In that right-hand fraction now, we now have I got to do that division, right? So I've got to divide this thing right here, this one. So the 2 divided by 2 is 1, the 6 divided by 2 is 3. So that means I'm going to have a 4, and then I'm going to have a x minus 3, and then I'm going to have a 2x minus 1. And on the bottom, I've got a 2x plus 1 times the quantity 2x minus 1. Now I'm really tired. And then I got to put all these in parentheses, and then I got to ask you guys what cancels out. So what cancels out, guys? Whew. Anybody see anything that cancels? What's that? Good. 2x minus 1. Yeah, we got a 2x minus 1 right here and a 2x minus 1 right there. So that quantity divided by itself is 1. What else we got? Come on, the hard part's done. What else cancels out, guys? 2x plus 1. Good. 2x plus 1. That whole quantity right there cancels out that whole quantity right there. Anything else? What's that? Yeah, x minus 3. You got an x minus 3 on the top and an x minus 3 on the bottom there. And again, anything divided by itself or anything over itself is 1. And I think that's it, isn't it? So all we have left now we multiply our fractions. So we multiply straight across the top, straight across the bottom. So on the top there, we've got a 4, and we've got the quantity x minus 4. Everything else, that's a 1, that's a 1, and that's a 1. So what we got then is, I'm getting some energy back again now. So we got a 4 times the quantity x minus 4 in the numerator. And on the bottom, everything canceled out in that denominator. That's a 1, that's a 1, that's a 1. The only thing we got is the x plus 3. And after all that, that's our answer. I think this morning when I did that, I actually went a little quicker, but it's the afternoon, I must be getting tired. So that is your answer right there. 4 times the quantity x minus 4 over the quantity x plus 3. All right, I'm going to keep going. Now, normally I would probably have to stop at this point. I think that's enough. But the next couple problems are pretty quick and easy, so I'm going to go ahead and do them. So hopefully you guys got all that. And so the next couple problems, let's see, what do I got here? Which ones do we want to do? I think we'll just go ahead and do these. So I'm actually going to do these right here. So I'll go off on the side and write them down. So the first one I'm going to do is, we have got, what's that over again? X plus 3, okay. So we got x squared minus 9 over x plus 3 equals 7. That is example 5A. Now that x squared minus 9 in the numerator on the left, we already factored that in the last problem, right? That's x squared minus 3 squared. So that's going to factor into the quantity x plus 3 times the quantity x minus 3. And then that's still going to be over the quantity x plus 3, and then that's going to equal 7. Now, do you guys see anything that cancels out?
X plus 3.
Good. So that x plus 3, that whole quantity right there, cancels that whole quantity right there. And that just leaves us an equation now that says x minus 3 in the numerator equals 7. And then we add 3 on both sides, and we get x equals 10. Well, that wasn't too bad, right? Now, well, I guess I'll save that hint for the next one. And you could check your answer real quick if you wanted to. You could use a calculator. You put the 10 in right here and right here. So that would give us 10 squared. That's 100 minus 9. That'd be 91 over 10 plus 3 would be 13. 91 divided by 13 is 7. So yeah, it checks. So that answer is good. It's supposed to be a check mark. All right, now before I do the next one, I want to show you one thing real quick. Again, these are pretty fast. I guess I'll show you down here. If I wrote something like this, if I wrote like, I don't know, 2x plus 5 over, I don't know, x minus 4. Now, you guys know you can't divide by 0, right? So what can that x right there, what can that not be? What would cause division by 0? What number can you not put in there for x?
4.
Yeah. If you were to put 4 in there right here, 4 minus 4 would be 0, right? You can't divide by 0. So that's what earlier I was talking about where it said identify any x values where the expression is undefined. We'll get into that more later. But you would want to write something like, x cannot equal 4. Because that would cause division by 0. Okay, because that's going to come into play on our next problem. So that's why I showed you that. So let's set up our next problem here. I think I can fit this one down here. This one we're going to write, this is example 5b. This is our last one. So bear with me. So we got x squared plus 3x minus 4 over x minus 1 equals 5. I think that's right, isn't it? Yeah. All right, so let me zoom in on that a little bit now. That's supposed to be a squared right there. Okay, so we got to factor that numerator. Finally, we get one of these where that's a 1, right? That's a lot easier when there's a 1 there. So on this one, we're going to do, what do we need? We need two numbers that multiply to a times c, which would be 1 times negative 4 is negative 4. And the same two numbers have to add up to b, which is positive 3. So let me set this thing up for a factor here. So it looks like this. That's an x, that's an x. So what are two numbers that multiply to negative 4 that add to 3? Anybody got it? Say again? 4 and negative 1. Yeah. That would work, wouldn't it? So if we did 4 and negative 1, if we multiply these, we get negative 4. If we add these together, we get 3. Okay, so then, all right, let's keep going. So then that's going to be, let's see, it's a positive 4, so we write plus, oops. So we write plus 4. And it's a negative 1, so we write minus 1. On the denominator, we still have our x minus 1. And now that's equal to 5. What cancels out? Yep, the quantity x minus 1 here cancels that whole quantity x minus 1 there. Anything divided by itself is 1. So now we have an equation that says x plus 4 equals 5. We subtract 4 on both sides, and we end up with x equals 1. Now, let's do the check on this one. Can I plug in 1 right here? That's our solution is 1, right? Can that be 1? What's that? That blue circle right there, if I'm plugging that, I'm plugging my solution here, x equals 1. I'm plugging this into my original equation. So if I plug 1 in right there, can I do that? Yes or no? No. Because if I plug 1 in right there, I'd have 1 minus 1 is 0. Division by 0 is undefined, right? That means that solution is no good. So this solution right here is no good, which means there's no solution. Now those last 2 problems, I know there's 2 problems exactly like that on your chapter 8 test. So there is no solution. That's terrible writing right there, but that's okay, we're almost done. Which you can also write like that, right? If you want to. So let's get an assignment up here for you guys. And that was a long lesson. So we are going to do, I should probably stop recording, but that thing's already long enough, so I guess it doesn't matter. We are going to do page 580. So page 580. We are going to do 18 through 34. And now let me stop my recording.